Welcome to today's lecture. This is Blessed Elvis. So in today's lesson, we are going to discuss the exponential functions. So before we dive into that, let's look at some of the indices rules that we might use for us to solve some of the indices, or rather some of the exponential functions. So some of the rules we have the multiplication rule. So according to the indices, when you are multiplying the terms of the same base, you add the powers. Let's say you have m power a multiplied by m power b. When you are multiplying the same bases here, that is m and m, you simply add the powers, that is a plus b. So in this case, we are just going to write on one base and then add the powers, that is a plus b plus b. So this implies that whenever you are multiplying the same bases, you simply add the powers. So let's say, for example, you have 2 power 3 multiplied by 2 power 4. So in this case then, we are just simply going to add the powers. So we are going to have 2 then added to power 3 plus 4. So in this case then, it's going to be 2, then 3 power 4, it's 7. So this is basically what this rule means. So let's look also at the division rule. According to division rule, when you are dividing the same bases, you subtract the powers. So let's say you have m power a over m power b. So in this case then, it's going to be m, then the numerator power, you subtract the denominator power. So this is how it is. So let's look at an example for this. Let's say you have 2 power 3 over 2 power 4. So this is going to be what? 2, then 3, we are going to subtract 4. So in this case, it's going to be 3 minus 4, it's negative 1. So this is basically how it is when you are dividing. Now, apart from this, let's look at another rule. Another rule is that whenever you have the power as the fraction, okay, what this means is that, let's say you have m and then you have a over b. In this case, it means that the denominator here defines the root of the base. So if we have a over b as the power, it means that you are going to find the root of what? Of b, and then m here. Then the numerator remains outside. So that is how it is when it comes to the power. So let's look at an example. Let's say you have 2, then let's say you have power 2 over 3. So what this means is that you are going to find the root of what? The denominator, that is 3. So it's going to be the root of 3, that is 2, of course. And then the numerator, that is 2, is going to be the power. That's how it happens. So now, having understood that, whenever you have an expression, let's say you have x power 2x plus 1, what should come into the mind is that for them to have this power, or for us rather to have this power here, it means we were multiplying the what? The same bases. So this is the same as x power 2x then multiplied by x power 1. Okay, so from what we have done previously, this is the same as, since we are multiplying the same bases, that is x and x, you simply write 1x and then add what? The powers, that is 2x and 1. So it's 2x plus 1. So hopefully you have gotten the concept where this came from. This came from what? From this. So just make sure that you understand this concept, because whatever we are going to be doing here is linked to that. Okay, so let's look at some of the examples. Let's say we have been asked to show that, 3 power 2x minus 1, let's say this is equal to 9x over 3. So how can we show that this is the same as this? How can we show that? So you can choose which side you want to show, if it's this side or if it's this side. What's important is applying the concept. So let's use the left side to prove that left side is the same as the right side. So in this case, by now we know that for us to have the power which is being subtracted here, it means we were dividing rather the same bases. So this came from what? From this power 1. I hope by now you understand how this comes about. Now, by now we know that when we have this is the same as 3 power 2 multiplied by x. Why? Because 2 multiplied by x here is 2x. So this is basically the same as this one here. Okay, because when we multiply 2 and x, we are still having 2x. So nothing has changed there. So here we have 3 power 1. And then when we raise 3 to power 2, it's what? It's 9. And remember, we have what? We have x there. So it's x over 3 power 1 is simply 3. So we have proved that this here is the same as this. So this is how we basically prove. Let's try to prove the right side also. So let's just remove this and then try to prove the right side. So the right side we have is 9 power x over 3. So let's try to show if this can produce this. So here we have 9 power x. So 9 power x can also be reduced as 9, or rather 3 power 2. Here we have x and then over 3. Okay, so this, of course, we know when we multiply 2 multiplied by x here, we are going to have what? 3 2x and then over 3. Then according to the rules, when you are dividing the same bases, that is 3 here divided by 3 here, you simply subtract the powers. But by power rule, we know that any variable, any value, any number which does not have the power, it means they have the power of what? Of 1. So here it simply means that you have 3 power 1. So since we are dividing the same bases, we are going to subtract the powers. So we are going to write 3, then 2x, and then since we are dividing with 3 power 1, the power 1 will be subtracted from the power of the numerator. So this is how we basically simplify such, or rather show that the given two values are equal to each other. So we have shown that this is equal to this. So let's look at another example. Let's say we have 2 power x minus 1. Let's say multiplied by 8, and then we have x plus 1 as the power. Let's say this equals to 4 power 2x plus 1. So how can we prove that this side here is the same as this side here? So you may go ahead and try this one. So in this case, let's try to prove the left side if it's equal to the right side. So in this case, let's reduce this 8 so that you may have also 2 there. So in this case, this is 2x minus 1, and then multiplied by, we know that 8 is the same as 2 to the third power, and then on the power there we have x plus 1. This equals to 4, then we have 2x and then plus 1. So this, in this case then, since we have this, we can simply, since we have this, we can simply multiply these 3 here throughout in here. Okay, so let's see what we're going to have. So in this case then, we are going to have 2x and then minus 1 multiplied by 2. These 3 multiplied by x here, we are going to have 3x, okay, plus these 3 multiplied by 1 here, we are going to have 3. Okay, then this equals to 4, 2x, then plus 1. Okay, so in this case then, since we have these same bases here, according to the rules, it means that you are going to add the powers. So in this case, we are going to have 2, okay, and then x minus 1, then plus 3x, then plus 3 equals to, so since here we are using the base of 2, even this one can be simplified so that we have the base of 2. We know that 4 is the same as 2 power 2, right? Okay, then the power there we have is 2x plus 1. Okay, so let me just wrap the top part here since it's unnecessary now. Okay, so in this case then, what are we going to have? Here, when we add this x, we add it to 3x, we are going to have what? 4x. So we're going to have 2 power 4x. And then If we add negative 1, we add it to positive 3, we are going to have positive 2. Okay, equals to this here. So here we have power 2. So we have the base of 2, that is 2, and then power 2. So if we multiply this power 2 throughout here, we are going to have 2 multiplied by 2x. It's what? It's 4x. So it's 4x here, and then plus, then 2 multiplied by 1 here, we are going to have 2. So we have shown that the left side is the same as what? As the right side. So this is how we show it. Make sure that you apply the English rules, and then you take note of all the rules that you need to apply for you to show the given values of the functions. So now let's go into solving the exponential functions. Let's say, for example, you have been given the function that is 3 power x equals to 81. So how can we solve such an expression? So to solve this, you simply have to simplify first. So here we know that 81 is the same as 3 power 4, right? So according to the English rules, when you have the equal same values, when you have the same values of the bases and you are equating, you can simply cancel them, and then you remain with what? The power. Okay, so this is how we solve it. So make sure that if you have the same bases here, you simply cancel them and then remain with the power. If we had the same powers, let's say we had x, let's say power 3, and then we have 9 power 3. If you have the same powers, you can as well as cancel the powers and then just remain with the bases. So you simply cancel what is the same. That's how we solve these. So let's look at another example. Let's say you have 8x equals to, let's say, 0.1, let's say 2, 0.25. So how can we find the value of x for this one? So the first step is expressing this into a fraction. So here we have 8 power x equals to, now 0.5 is the same as here 0.5. We know 0.5 is the same as 1 over 4. So this is 1 over 4. So 1 over 4 is what gives 0.25. Rather, sorry for mentioning 0.5, it was 0.25. So 0.25 is the same as 1 over 4. So for some of you who would want to know how this came about, we know that this 0.25 is the same as 25 over 100. So what you do here is you get the significant values, and the significant value starts from 1. So the significant values we have here are what? 2 and 5. That's why I've written what? I've written 25. And then before a decimal point, the value that is here is your 1. So this is the 1. Then the number of values you have after a decimal point determines how many zeros you are going to have. So since we have 2 values here, it simply means we are going to have what? 2 values here. That's why we have over 100. And then simplifying this, 25 into 25, it's 1. 25 into 100, it's what? It's 4. So that's how we convert from decimal points to what? To fractions. Let me give another example so that you can just have a clear picture of this, because I'm not going to talk about this again. So let's say you have 0.125. So how can you convert this? So you get the significant figures, that is 125. So you write 125 over the 0 here. Okay, 0 here represents 1, and then the number of figures you have after a decimal point determines how many zeros you are going to have. So in this case we have 3 values, so it's going to be 3 zeros. So that's how we simplify. But apart from this, you can as well have a value in front instead of 0. So let's say you have 1.25. How can you convert this? So since 1 is also a significant figure, you simply have to also include it. So you're going to have 125 over, since here we have a value here represents 1, so we're going to have 1. Then the number of figures you have after a decimal point determines how many zeros you're going to have. So in this case it's 2, since we have two significant values. So this is how basically we convert from, and then you simplify. This is how basically we convert from decimal points to fractions. However, we are not specifically looking at that. I was just explaining the point here. Hopefully you have gotten where this came from. So in this case, we can now simplify this. We know 8 is the same as 2 power 3, right? And then outside here we have what? X equals to, then this one is the same as 4 power negative 1. Whenever you have a fraction and the numerator of 1, let's say 1 over 2, this is the same as 2 power negative 1. Let's say you have 3 power, okay, rather 1 over 3, this is the same as 3 power negative 1. Let's say you have 1 over 5, this is the same as 5 power negative 1. Hopefully you have seen the pattern that is forming there. So it's the same as you have 1 over 4. If you have 1 over 4, this is the same as 4 power negative 1. So this is how this came about from that concept that I am just from explaining there. Okay, so in this case here, when we multiply this 3 multiplied by x here, we're gonna have what? 2 3x, and then this equals to, this 4 we know is the same as 2 power 2, and then outside there we have negative 1. So let's simplify this further. So we have 2 power 3x and then equals to, now here when we multiply this 2 with negative 1 here, we're gonna have negative 2. So this 2 and this 2 will cancel since they are the same. So we are going to remain with only the powers, that is 3x equals to negative 2. Then when we divide 3 to both sides here and there, we're going to remain with x here equals to negative 2 over 3. So this is the value of x. So let's look at quite complicated questions. So let's say, how can you solve this? Let's say you have 2, let's say power 2x, then we have plus 3, let's say plus 1, let's say this equals to 9 multiplied by, let's say 2 power x. So how can we solve the value of x for such an expression? So let's simplify this part here. So we know by now that this, for us to have the addition of the power, it means they multiplied the same what? The same bases. So it simply means we had 2x multiplied by 2 power 3. Okay? Then plus 1 equals to 9 multiplied by 2x. So let's also simplify this. Since we have 2 power x here, this is quite complicated, so let's simplify it. So we know that this is the same as 2 power x multiplied by power of 2, because power of 2 multiplied by x here, it's what? It's 2x, so it's just the same as this one, so nothing has changed there. So all of this we are multiplying with what? With 2 power 3. Okay, let me just simplify that. 2 power 3 is what? We know it's 8, right? Okay, then plus 1 equals to 9 multiplied by 2 power x. Now, after you have reached this point, what we have to do is let's equate this value here, the value of the power of x, to a certain variable. You can use n later. However, this time let's use y. So let's say where there is 2x, 2 power x rather, let's say there is y. Let's just let this equal to one variable so that we can see how we can simplify this. So this means that whenever there is 2 power of x, we are going to replace with what? With y. So in this case, when we replace here with y, we're going to have y power 2 multiplied by multiplied by 8. And then here we have plus 1 equals to 9 multiplied by, here where there is 2 power of x, it's what? It's y. So we're gonna need it later when we simplify that. So in this case then, okay, let me just wrap all these so that we can have a lot of space. So in this case then, we're gonna have 8 multiplied by, okay, we're gonna have 8 multiplied by y squared, it's what? It's 8y squared, and then plus 1 here equals to 9 multiplied by y, going to have 9y. So let's take this 9y to the left side. So we are going to have 8y squared. Then this is positive. When it comes to the left side, it's going to be negative 9y. Then here we have plus 1, and here we remain with what? With a 0. So what we have up there is the what? The quadratic equation. So quadratic equations are very, very much important to understand because they are used in most of the equations. Whenever you are solving them, you are going to find them. So make sure that you understand how to actually solve them. So let's use the factorization method. So we know that the product here is the coefficient of y squared multiplied by the constant, that is 1. So 8 multiplied by 1 here, we are going to have 8. Then the sum is simply the coefficient of y. So in this case then, the coefficient of y is what? Is negative 9. So it's negative 9. So what values can we multiply for us to have 8? And then when we add the same values, we have negative 9. Okay, so it's what? It's negative 1 and negative 8. Because negative 1 multiplied by negative 8, it's positive 8. Then negative 1 minus 8, it's negative 9. So we are going to replace these values where we have the coefficient of y. So we are going to have 8y squared, then minus here we have 1. So 1 is the same as the same coefficient which is present in the given quadratic equation, so it's just the same as y. And then minus 8y, then plus 1 equals to what? Equals to 0. So in this case, let's factorize y here since it's common. So we're going to have 8y, and then minus, when we remove y here, we're going to remain with 1, because y, when we remove y from this 2y, we are going to remain with 1y here, and then when we remove y here, we are simply going to remain with what? With just 1. Okay, so that's how it is there. Then here, there is nothing that we can factorize here. So since there is nothing, let's just factorize negative 1. So when we move negative to the 8, we are going to add, rather when we move negative from 8, we are going to have 8y. Then negative multiplied by positive, we are going to have negative 1 equals to 0. So in this case then, since this and this are common, or rather they are the same, we are just going to write on one of them. These are called the common terms. So since we have the common terms, we only write one term. And then you also write the values that are outside the brackets, that is y and negative 1. Okay, all these equal to what? Equal to 0. So in this case, let's solve the value of x. Okay, so let me just wrap the top part here so that we can use the space. Okay, so in this case then, solving this, we know it's going to be 8y minus 1. So we are equating both of these to 0. So this is going to be equal to 0, and also y minus 1 going to equal to 0. So let's take 1 to the right side. We're going to have 0 plus 1, it's 1. And then when we take also 1 here, when we take it to the right side, 0 plus 1, it's 1. And then here we divide both sides by 8. Okay, we're going to have y equals to 1 over 8. And then here we're going to have y equals to 1. Okay, so these are the values of y. But remember, we have just borrowed y. The original equation had x, which was this. So we had 2 power x equals to y. So in this case then, let's replace wherever there is y with the values that we have found here. So let's see what you're going to have. So let me just wrap some of the things that we don't need here. So make sure that you follow up. So whenever you use other letter, you have to get back to it, and then you replace where you had y, or rather where you had replaced that value with whatever you have found. So let's replace first with 1 over 8. So where there is y, we are going to replace with 1 over 8. So we have 2 power x equals to 1 over 8. Or rather, let me just replace them at once. We also have 2 power x where there is 1, or rather where there is y with 1. Okay, so let me now just remove these, since we have gotten our values. So in this case then, we're going to have 2 power x. Remember, I said when we have the numerator of 1 over n value here, you simply write the negative 1 of the power of negative 1. So in this case then, this is going to be equal to 8 power negative of 1. Okay, then in this case we have 2 power x. Now, we know that any value, n variable or n number raised to power 0 is 1. So since we have 1 here and we have 2 here as the base, we know this is the same as 2 power 0, because 2 power 0 is simply what? 1, and we have 2 here. So for us to cancel this 2 with whatever value we are going to have here, we have to introduce a 2 here. So the only way we can rather introduce the 2 here is by raising 2 power 0, since we have 1 here, and 2 power 0 is 1. Okay, so that's how this has come about. Then here we can as well simplify this further, because we know that 2, or rather 2 raised to power 3 is 8. So this is the same as 2 power 3, because 2 power 3 is 8. So it's just the same value that we have there. So in this case then, we are going to cancel the same bases, since we have 2 on the right side and the left side. So this is basically the value of x for this part here. So let's find the value of x on this part as well. So in this case, we are going to have 2 power x equals to, when we multiply this 3 with the negative here, we are going to have rather 2 power of negative what? 3. So x, rather in this case, is going to be equal to negative 3. So in this case then, we have x equals to negative 3, and also we have x equals to 0. So these are the values of x. So let's look at one last example so that we may have a clear picture on how these things are done. So let's say we have 3 power 2x, and then minus, let's say we have 12 here, and then let's say this is multiplied by 3 power x, and then let's say we have plus 27. All these equal to, let's say, 0. So how can we simplify such? So in this case, we know that this power here is the same as 3 power x multiplied by power of 2, because power of 2 multiplied by x here, we're going to have 2x. So it's just the same thing. So you have to think of the way in which you can simplify this such that you have the same powers. Then plus 27 equal to 0. So in this case, we have 3 power x. So let's replace where there is 3 power x. Let's say we replace with what? You can use n later. Let me just use p in this case. Okay, if we use p, then it means where there is 3 power x, we are going to write what? P. So in this case, it's going to be p squared, then minus 12, where there is 3 power x, I replace with p, and then plus 27. So what we have formed is the quadratic equation. Okay, so as said earlier, make sure that you understand how to solve the quadratic equations, because most of the questions here involves quadratic equations. So here, let's find the product, the sum, and the factors. So what we are using here is the factorization method. So for product, you multiply with the coefficient of p squared multiplied by the constant number, that is 27. So coefficient of p squared is simply 1. The value that is here is 1. Then multiplied by the coefficient of the constant number, that is 27. It's going to be 27. 1 multiplied by 27 is 27. Then the sum, you simply get the coefficient of p, which of course is negative 12. So for the factors, you simply find the values you can multiply to have the product, and then when you add the same values, you have the sum here. So what values can we multiply for us to have positive 27, and then add the same values for us to have negative 12? So which values do you think can be those? Okay, so it's negative 3 and negative 9. Because when we multiply negative 3 multiplied by negative 9, it's positive 27. Then if we add negative 3 to negative 9, it's negative 12. So in this case then, these factors will be replaced where there is the coefficient of p. So in this case, we're going to have p squared. Then when you replace here with these values, we are going to have negative 3p, and then minus this one also negative 9, p and then plus 27. All this goes to what? Go to 0. So in this case, p is common here, so we're gonna factorize it out, and then here we are going to remain with 1p. When we move p from here, we are going to remain with 1p minus when we move p here. When we move p here, sorry for the disturbance. I don't know what has happened. Okay, sorry. Yeah, when we move p here, we are going to have 3. Okay, then minus, we know 9 can go into 27. How many times? 3 times. So we can factorize 9 as well. And then here we are going to remain with p. And then negative rather, multiplied by positive here, it's negative. Then 9 into 27 goes how many times? 3 times. So it's 3. All of this goes to what? Go to 0. So in this case then, we have this and this. So these are called the common factors. So we are just going to write on one factor since they are common. Then you write the values that are outside the brackets, that is p and negative 9. So we are going to have p minus 9. Okay, so all of these equal to 0. So let me just wrap this. So here in this case, okay, since we don't need these, let's remove them since we don't need them anymore. Okay, so in this case, we are going to have these solved by equating each term to 0. So p minus 3 equals to 0, or p minus 9 equals to 0. So when you take negative 3 to the other side, it becomes positive 3. And then when you take 9 to the other side, it becomes positive 9. So these are the values of x. So here we have p equals to 3, or p equals to 9. Now remember, we have just borrowed this p here. Our first expression was 3 power x, which we had said that it be equal to what? Equal to p. So in this case, we are going to replace where there is p with the values we have found. So firstly, let's replace with 3. So we are going to have 3 here. And then secondly, let's replace with 9. So we're going to have 9 here. So here, this is the same as power of 1. 3 power 1 is simply 3. So it's just the same thing. So since we have the same bases here, we can cancel them out. And then remain with x equals to 1. Or here, this is the same as 3 power 2, because 3 power 2 is 9. Since we have the same bases here, we can as well cancel them out. So we have x equals to 2. So in this case then, our values of x are x equals to 1 and x equals to what? Equals to 2. So these are the values of x. So this is how basically we answer, or rather find the values of different exponential functions. So this is all for this video. Thanks once again guys for staying this far. Please like, subscribe, share and turn on the notification button so that you are updated whenever I upload a new video. Stay blessed.